We have the following objectives for today's lesson. Find the number of ways to arrange n distinct objects along a fixed circle and solve problems involving circular permutations. Let us deal with this problem. 8 people are to be seated at a round table. How many seating arrangements are possible? We know that when 8 people are placed in a line, there are 8 factorial or 40,320 arrangement of the 8 people taken 8 at a time. However, when they are arranged in a circle, some of the arrangements are alike. These arrangements fall into groups of 8, each of which can be found by turning the circle. So therefore, the number of really different arrangements around a circle is 1/8 of the total arrangements in a line. So therefore, we need to multiply 1/8 times the 8 factorial. So we have this equation. So 8 factorial divided by 8 is obtained by canceling the common factor, which is 8. So we have now 7 times 6 times 5 times 4 times 3 times 2 times 1, or 7 factorial, or the factorial of the quantity 8 minus 1. So the number of ways to arrange n distinct objects along a fixed circle is obtained by P sub n equals the factorial of the quantity n minus 1. So n stands for the number of objects to be arranged. Let us deal with the first example. In how many different arrangements can 6 ladies sit around a table? So for the solution, let us determine the value of n. So n here is 6. Using the formula, the factorial of the quantity n minus 1, we substitute the value of n, which is 6. That's why we have 6 minus 1. 6 minus 1, we have 5 factorial, and the value of 5 factorial is 120. So it means that we have 120 arrangements, of which the 6 ladies can sit around a table. Let us have example number 2. In how many ways can 5 couples be seated at a round table? So for the solution, let us determine the value of n. So the n here is 10, since we have 5 couples. So using the formula again, we substitute the value of n, which is 10. So 10 minus 1 is 9. So the value of 9 factorial is 362,880 ways. Let us deal with this problem. 8 people are to be seated at a round table. One of them is to be seated close to the window. How many arrangements are possible? You have to take note that the 8 people need to be placed relative to a fixed point, which is the window. So, if n objects are arranged relative to a fixed point, we will be using n factorial permutations. Even though the objects are on a circle, the permutations are linear since a reference point has been established. So it means that we need to get 8 factorial. And the value of 8 factorial is 40,320 arrangements. Let us observe the arrangement of different beads in a bracelet, keys on the key rings, and the like. They are circular permutation where the arrangement is reflexive. Given this case, the total number of permutations of n elements taken altogether is determined by the quantity of n minus 1 factorial over 2. But what if the bracelets, keyrings, and the like have a lock? Then, the permutations becomes linear, and it can be denoted as n factorial over 2. Let us deal with this example. In how many ways can 7 keys be arranged on a keyring that has no clasp? So for the solution, the value of n is 7. So we will be using here the formula, the quantity of n minus 1 factorial over 2, since the keyring has no clasp. Then substitute the value of n, which is 7. 7 minus 1 factorial over 2 is 6 factorial over 2. The value of 6 factorial is 720 divided by 2. So we have 360 ways of arranging the 7 keys on a keyring that has no clasp. Let's have the fourth example. In how many ways can 7 keys be arranged on a keyring that has a clasp? So for the solution, we have n, which is 7. So since the keyring has a clasp, we will be using the formula n factorial over 2. Substituting the value of n, which is 7. So we have 7 factorial over 2. The value of 7 factorial is 5040. We divide it by 2. So we have 2520 ways of arranging the 7 keys on a keyring that has a clasp. Let us have the fifth example. In how many ways can 4 boys and 4 girls be seated alternately at a circular table? Let us sit the boys around the table first. They can be seated in 4 minus 1 factorial. So the boys can be seated into 3 factorial ways. The girls then will have 4 factorial ways in sitting between the boys. So for the solution, we have 3 factorial times 4 factorial is 6 times 24. And 6 times 24 is 144 ways. So we have 144 ways of sitting 4 girls and 4 boys around a table alternately. Try doing this on your own. Until our next session, thank you and enjoy learning.